Hi everyone, my name is Richard Smith from School Energy Efficiency.
Hi, and I'm James Venice.
Okay, so we're here to talk a little bit about the climate emergency. We've got a presentation we want to share with you, and we're going to try and share it right now. Go for it, James. All right, so here we go. We're talking to the void, everyone, so this is an unusual circumstance, and hopefully you'll find this really interesting. So there we are, you can still see us. And here we are, climate emergency. It's all about have we reached our tipping point, okay?
So where are we at with our climate emergency? It's been declared by many councils, schools all across the country about a year to a year and a half ago. So what are we actually doing about this? And that's the question we want to pose to you today. How bad is the situation? What are we doing about it? And where are we actually potentially going to end up in the future?
Okay, so global factors. These are things that affect you. So think of you right in the center of this circle and look at all the things that surround you, from environment, energy, food, but they're all interconnected with politics and freedom and poverty and people. That's something I've learned in my journey to learn about sustainability. So think about you and what affects you, and it's an awful lot.
So a tipping point is a point in a system where we move from one state or regime A in this category, in this slide, to regime B. And that means we're at a point of fairly stability. You think about a chair and it's up on its four legs, it's fine. You can rock back on your chair like you probably have in many of your classes, especially in secondary school. And then you're going to tip back forwards and you're going to be back onto your four legs. But if you just push that just a little bit too far, that chair's going over and you're going to be flat on your back on the floor. And that's kind of what we're talking about in terms of a tipping point. Are we reaching a point now where we're actually not going to just rock back onto those front four legs when we're actually going to fall over backwards into the next regime, where we're actually going to be stuck?
And that's the thing, James, isn't it? Because we don't know where we are in that, do we? We don't know what the change is going to be. It may be some change, maybe a massive amount of change. And that's what the scientists and the rest of the world are trying to work out. So the greenhouse effect. Now, many of you probably have done this many times at school, but just very quickly, the sunlight comes from there in all its forms and hits our atmosphere. Now, some of it bounces right off the atmosphere. Some of it gets reflected off the cloud base, some off the ice on the north and south poles, and some of it actually gets through our atmosphere and starts warming up the ground. Now, as you can see here, that when you have greenhouse gases, it's a good thing. We would be freezing cold if we didn't have sunlight that stayed and warmed up our atmosphere. So a little bit of carbon dioxide is a good thing. The problem is we've got an enormous amount of carbon dioxide that we've helped create. So it's actually rebounding the sun's energy back down onto the earth. So slowly over hundreds of thousands of years, it's been warming up. But this latest 100 years, it's been warming up very quickly. That's the problem. And it's going to have a massive amount of impact, isn't it, on what happens on this planet?
Yeah, so as that layer of greenhouse gases gets thicker, we're re-radiating more warmth and retaining more heat. And that's adding to this global change in our climate. And that's what we're concerned about.
Yeah, because it doesn't just affect us, it affects all the species on the Earth. It's everything.
So if we talk about a shifting climate as opposed to global warming, we're talking about this here is a normal bell curve of cold weather, some hot weather, and then the sort of average, the big lump in the middle is what we normally expect, the average temperature. And then if you look at the graph there, the probability of occurrence is obviously running down the left-hand side. So if we animate the slide, what you'll see is the increase in average temperature. So we're going from current to future climates. And what we'll see is we're going to have less cold weather, or the very extreme cold weather, a lot more of the hot weather that we've been used to and we have been receiving. And then we get into the new extreme hot weather, which is hotter than we've ever experienced before. And, you know, in the UK, we're quite lucky in some respects because we've got a fairly moderate climate. It's not too hot, it's not too cold. But you imagine being in one of those more extreme environments where it's very difficult to live because of the amount of water, the amount of heat. And it's not going to take a huge amount of temperature change to actually, starve those places of the water that they need. And then we can't grow crops, etc. Then we're really in trouble.
So, I mean, sometimes we talk about the south of England becoming more like the Mediterranean. Okay, some people might say that's great, but just think about what's going to happen to the Mediterranean. If that's going to heat up, how much of that would be livable, from season to season? It's going to be extremely hot. Some places may be so hot you actually can't live there for periods of time. It could be that serious.
So we've seen lots of examples of this in Australia, the bushfires last year. Incredible amount of vegetation, just caught fire just because of the different environmental factors there, drier climate during that time. The bushfires start, which happen naturally, but then the winds had changed as well. And those winds spread that fire significantly more than they would normally have done.
And this is happening in America a lot as well, isn't it? There's some horrific fires out there.
So as I say, it doesn't take a lot. This is a farmer and his farmland. It's just that little bit hotter. And now his land it's not farmable. What's he going to do? He's got no option. He's not going to be able to live there. And this is where we get what we call climate refugees, where people have to move into different areas just to survive. And I think we're going to see a lot more of that, which is one of the scary factors that's going to happen. Closer to home.
Yeah, a little bit of flooding there, isn't there? And this is something that could be happening in our country more and more. So it's forecast, actually, from what the scientists think in their models, is that Manchester might get wetter, if that's even possible. But yeah, so that side of the Pennines may get wetter, and you may find, on the other side of the Pennines, it may get wetter too. And that will be in the winter times, but it will get drier, perhaps, in the summer times, and especially down south. Now, I bet a lot of you don't realise that, actually, the southeast has been in a drought situation for quite a few years now. They don't have enough rainfall to keep enough drinking water and the different uses of water in their area. They have to have it shipped in. And there is no water network in this country. It's not like the gas network, electricity network. All the different water companies don't join up. So that's another problem we've got to crack, isn't it? If one place has got more water and one place has got less, then we need to balance it up and then bring that to Europe. How are we going to balance up the water there? So there's all these problems that need to be solved.
But the changing in those weather patterns is really quite incredible. And you think about the warmth, and because it's so much warmer, we're generating or evaporating more water from the oceans, etc. And that's what's leading to these higher levels of rain. And so the changing patterns, not just in the UK, but across the world, are going to be significant. Sea level rise, another great problem we have. These lovely low-lying tropical islands, you think, oh, that'd be fantastic to go on holiday. But the chances are that as the water in the oceans increases in temperature, it's actually going to expand slightly, plus melt from the ice caps is going to actually raise sea levels, in which case these low-lying islands just aren't going to exist anymore. You can see from the picture there that the sort of stuff coming down the right-hand side there is where land was, and it's just cutting away into the island.
And the other thing, there's probably over half the cities, big cities on this planet, are actually on the coast. So over the next 100 years, as the water rises, actually these cities are going to have big problems.
I like this stat, but I don't like this stat. Antarctic ice loss each year would make 9.8 quadrillion 1-inch ice cubes, or 1,360,000 ice cubes per person on the planet. When you start thinking about that 1,360,000 ice cubes each, that's an awful lot of ice and an awful lot of people. So that melt is significant, and it will, as you say, make a difference to sea level rise.
And if you look at some of the NASA pictures of the North Pole, you can see over the last 20 years how much it's been shrinking. Every summer, it seems to be getting smaller and smaller. So it's something that's quite visual in terms of climate emergency, in that, this water, this ice is going somewhere. It's eventually slipping off Greenland as well, because, ice in the water, won't raise the sea level, but ice falling off land and into the sea, that's the killer.
I've been lucky enough to go down to Antarctica with a man called Robert Swan, who was the first man in history to walk to both the North and South Poles unassisted. And ironically, he posted recently that it's now virtually impossible to get to the North Pole because it doesn't really exist, because it was just a lump of ice.
Mhm.
Scary stuff. So world population, the pink line shows the increase. So we've kind of peaked in terms of the increase in population, but it's still massively rising. And I like to think about this. When my mum was born in 1940, there was only sort of just about 2.5 billion people on the planet. In her lifetime, there are now 3 times as many people, which is incredible. 3 times as many people living on the planet in my mum's lifetime. Now, that's creating an incredible strain on the natural resources that we have on this earth. Okay, all those people have got to be fed, watered, somewhere to live. And so as population continues to increase, and we're looking, and they're predicting it's going to reach 10.9 billion, that's a significant problem. And if we have marginalized areas that we can no longer live in because of climate change, then where are all those people going to go? We're going to be moving people towards the more temperate climates. And we're talking potentially about lots of climate refugees. And then how do we deal with all that?
Because, I mean, the good news is that we are starting to plateau in terms of numbers, but that is still billions of people more that we've got to look after. And if you put into that equation that between 500 million to 1 billion people don't have access to electricity still now, and that's amazing. And at some point they will, and they should have the right to get access to it. So we just don't want them to repeat our problem of what we did in the past since the Industrial Revolution. And I think we have responsibility as a country, as Western nations as well, to actually help the developing nations to get clean energy and to do it safely.
So the UK energy comings and goings, this graph now is probably 10 years old, something around that sort of age. And it was showing us where we were at in terms of how we generate our energy and where we use it. So if you look over to the left-hand side, you can see imports, wind and wave, hydro, nuclear. But then the vast majority of the power that we're generating there is through petroleum, manufactured fuels, natural gas and coal. And all that's coming in to the left-hand side where it says power stations. Then you look over to the right-hand side and say, how are we using this? And we've got the iron and steel industry, other industry, transport, domestic use, various others. We've got a few exports. But the big yellow tube that's coming out the side there is the bit that I find the scariest: conversions, transmission, and distribution losses. You know, we're running on an antiquated system. It's out of date, it's inefficient, and we need to upgrade it. We need to change that. The Industrial Revolution has been fantastic in terms of allowing us to develop. However, things need to be superseded. And that's kind of where we're at right now.
Can I just stop on that a second? Because all of those things on the left-hand side, all their job is to do is to get a propeller blade to turn around. So you're turning a magnet inside some copper wire to generate electricity. That's what they all do in essence. And the good news is the coal at the bottom is really starting to shrink. And then at the top, you've got the wind is really seriously increasing and will continue to increase. And when you add in solar as well, that's going to be great. We're going to go much greener on the grid, but then we've got a lot of electric cars to actually be able to put on the grid and get energy. And also we've got to sort out heating, which is mainly from natural gas in the moment. And so we're going to need loads more electricity. So there's a lot to do still.
So we're talking about the transition from fossil fuels over into mostly renewables. And it is good news. You can see from the graph here, this is of grid carbon, which is an app you can get on your phone. You can see that at the top there, 41% of the energy was being produced by gas, but look what's underneath it: 16% solar, 15% wind. Then we've got a chunk of nuclear and some biomass. Then we've got some imports. You see coal right down at the bottom there, nothing. So this was on a summer's day, I would imagine, a spring day in 2019. So we're moving in the right direction. Yeah. And from this one, you can see it shows nicely the solar that we're generating. If you look at the graph, you see the yellow that comes in underneath the blue at the top, and you can see how much we're starting to generate. and the green obviously under that via wind through these renewables. Now there is problems with renewables in that we can't just turn them on and off when we need to, but we're learning to manage that, and that's really important. And the storage of energy is going to be really a significant problem that we're going to need to deal with across the next few years. But it's good news that we are generating a hell of a lot more of the energy that we require through renewables rather than coal and fossil fuels.
Okay, so look at this one here. This is all about household emissions. So these are your homes. So it's comparing 1990. And you know, whenever people say we need to go net zero, or we need to, every so many years, we need to cut it by this amount, it's all tied to 1990. So whatever carbon emissions were in 1990, that's where we start. And it shows here a normal household where all the energy is used. So there's absolutely loads in heating and loads in transport. Transport is the really awkward one, where actually emissions in transport has not gone down over decades. Now, yeah, cars have got better, of course, the emissions coming out of an individual car, but we have more vehicles than ever. So actually it's plateaued quite a bit, which is why going to electric or hydrogen vehicles is really important. So you've got quite a lot of electricity. We all like our aviation, our planes to go on holiday, and there's a whole chunk on waste and diet. That's the stuff that ends up on your plate and the carbon involved in getting it there, basically. So when we got to 2017, you can see how they've all decreased, which is brilliant. But there in 2050, a couple of years ago, our UK aim was to be 80% cut from 1990 on emissions. So yeah, there was a sizable cut. So the big ones left were really, diet was still fairly big, and aviation was still up there because that would take a long time to change. But actually written into law now is that we're going net zero. So by 2050, this country in law has signed that we are doing no carbon. Now that may mean offsetting in different ways, which we can talk about later, but see how much it actually changes your household. It's next to nothing on everything. Aviation is probably the one which is the stickler, because you buy a plane now, it's probably going to be flying in 20 years' time. So we actually need to start bringing in fuels that use biofuels, planes that use biofuels, or maybe a little bit of electricity here and there, or take less plane journeys, basically. That's one way of doing it.
I suppose that's one thing COVID has done. They will have significantly reduced the aviation issue over the last year, but that's not going to be the result. Everybody's going to be back off on holiday as soon as they possibly can, I'm sure. So,
yep. Okay, so this one here is, I did my master's at Centre for Alternative Technology. So if you look that up, it's a great place. We've had many decades of looking at the climate emergency and how to solve it. Now, this is their projections based on the science of where we could be if we do something. Yeah, so the top one is if we don't do a lot. That's why it's in red, everyone. Yeah, and so 4 to 4.8 degrees Celsius. You think, well, that's not that much, is it? No, that could cause serious danger to many countries around the world that would make parts of it completely unlivable. And some parts of it only livable at some point. So people are going to have to start migrating if it's that bad.
And those low-lying islands,
gone.
They won't be there.
The ice on the polar caps will be severely reduced. I mean, it is a slow process, but over time they will be gone and the sea will go up. Okay, so current policies, you can see there, it's sort of flattening out at 3-ish, something like that. And if you want to be a little bit optimistic, 3 degrees, no, that isn't good. That is still, bad things will happen, and we've got a lot of problems to solve, which is doable. But if we make changes early on, and you can see those green ones at the bottom, if you make changes early on, it becomes an awful lot easier. And you can see the very, very bottom one, the 1.5, which is where the Paris Agreement was trying to get to, is we want to limit the change to 1.5. That's as good as it's going to get, everyone. That really is. So we've got a big fight in our hands to get the best outcome we can get by 2100. And if you think about it, you guys watching this now, most of you are going to be alive. Hopefully all of you will be alive then. So it's in your lifetime. So think about your kids, your grandkids. They're going to be living this for a lot longer than that. So what are you going to do?
Yeah, I mean, you look at if you look just back to sort of 2014, 20 years time from where we are now, it's going to be significant by that stage. We're really going to have shown our hand by then, and we really need to make these changes now. Remember, the experts are saying that 1.5 would be the ideal. We're already nearly there. And they're saying that 2 degrees could be that cutoff point for that next tipping point where we're going to tip over and those ice caps are going to continue to melt whatever we do. And that's going to mean that sea level rise, etc. So now is the time to act. We don't have the time to mess around anymore. We need to start making those changes.
Yeah, I quite like this image. Now, you can think of greenhouse gases in the atmosphere as being a bath, right? So you're filling it up. So this is human greenhouse gas emission rate. It's coming out the tap, okay? So it's filling up because the greenhouse gases are in the atmosphere for thousands of years. Methane breaks down relatively quickly, but your carbon dioxide, no, it's there. And actually, you could add the oceans in here because the scientists over the last 10 years done a lot of science on what's happening in the oceans, and they're absorbing a lot of the carbon dioxide. Okay, so they're also carbon sink, but they're acidifying, which is bad for what lives in the sea, which is an awful lot. And we need it. We need the lots of food that comes out of there. So at the bottom is the natural carbon sinks, but it's not a lot. It really isn't. And at the tap, we can start coming up with technical ideas of actually, artificial carbon sinks. We could capture the carbon and put it underground where the gas used to be, the natural gas, stuff it in there. But just turning off the tap doesn't really stop the climate emergency. It's just keeping it in the atmosphere. Okay, what we want to do is actually drain this bath, and that's going to take a lot of effort.
So, is it all about sacrifice? People think, oh, it's all the green agenda. What have I got to do? I've got to give everything up. I've got to be super clean. I can't do anything. Well, there is the rise of the vegan. Yeah, and eating less meat will make a significant difference. But we can all make a difference. I'm not suggesting that everybody has to do this, but just by, one day a week, if we reduce the meat intake by a seventh by everybody just going meat-free for one day a week, that would make a massive difference. I've been lucky enough to go down to a place called Wilpoldsried in Germany, which is a fantastic little village in Bavaria. And they've really changed the way they live. And it's not about sacrifice. It's all been a very positive experience. You can see from the picture there on the end, they've got solar panels across the roof of their changing rooms, so their new swimming lake and their sports centre, but across all of their community buildings. And on the horizon, you can see through some of the 11 community-owned wind turbines. They're generating huge income by exporting electricity. They have their own district heat system. They take the gas that they generate from the cow poo, because it's a dairy area, and they turn that into power and generate what they call energy via CHP, combined heat power. They even filter their water through their natural reed bed before they put it back into the river. They're generating a huge income, and that's allowed them to spend and create an income for the village. It's incredible what they're doing down there, and it's nothing new. They're just using existing technologies and putting them together in a smart way and taking advantage of some of the government incentives to move over towards clean, renewable energy. We can do this, but it just takes...
Quite idyllic, isn't it?
It is. It just takes, as it says there in this, citizens' participation and ownership. It's them taking control. They use their local wood. They store stuff. They've got smart grid operations going on. They use photovoltaics. They use wind. And they use biomass. It's just incredible. So where are we now? Before the whole COVID, we started to have some student strikes. Greta has been instrumental in that and started that whole thing off. But it's all very well as saying we need to do something, but we actually need to do something. We actually need to start taking some action. And being the voice that talks to those politicians, the people that are making the decisions, is incredibly important. But also we need to start taking personal steps, making choices that we think are important to make a difference to our environment.
And really that's what Greta's message always has been.
Yeah.
And there's some really good documentaries on the iPlayer, on the BBC you could have a look at, which tells you about her journey and what she's asking people to do. She just drills down on the problem, on the science, and she'll continually say, just look at the science. That's all I'm asking you to do, and make changes. Because here, Extinction Rebellion, hopefully you've all heard of them and the actions they've took in London. I mean, me and James actually sat down on the Strand, I think. It seems ages ago now, but there's a lot of goodwill in the country and across the world in that we need to make a change. And it's convincing the decision makers, the people at the top who hold the purse strings, that it's not in the future anymore. It's right now. This is the decade of change. So we're talking about 2020 to 2030. If we can actually do stuff now, it will pay dividends much better than leaving it later.
Yeah, I mentioned the idea of a tipping point. A tipping point from an environmental point of view would be the ice caps melting, the sea level rise. But a social tipping point is also something that we should consider. And interestingly, I found this fascinating, that statistics show that it's actually only 25% of the population needs to believe that this climate change is that much of an issue, that it is an emergency and that we do need to act on it, that will be a social tipping point, and it will now be no longer socially acceptable to use fossil fuels and move over to renewables and a cleaner environment. And that's what we need to do. You're part of that 25%. So what is your vision of the future? Because we haven't got much time. We haven't got much time left in this presentation. We haven't got much time in life. So is it the darker future? Are we going to be at war? Are we going to be in problems? There's going to be fights over water, fresh water. You know, what are we going to do about all this immigration issue we have? How do we deal with that? Or are we going to make the changes that we want and that we need to make and have a more holistic look at where we're going in the future and live more in harmony with nature? And I think that's really important. So where do you think we're at now? Where do you think we're going to? Because that's absolutely key.
And I think it's really important to have a positive image in your head of what you want it to look like, because you've seen the pictures there of Walpole's what it could look like. Now, we don't all live in villages, but you can have a very beautiful city landscape with lots of greenery, lots of solar panels and renewable energy about, and actually cleaner air, everyone. Not all this smog and yuckiness that my 6-year-old really hates. So it can be very positive.
So we're talking about current trends and probable futures, and we've already looked at that on the graph that Richard was explaining earlier about where we're ending up with, anywhere between 1.5 and 4.5 degrees of climate change temperature rise to our preferable futures. It's about starting now and taking that action,
because you can't do things in massive steps. Yeah, you got to think of it in small steps that you build up to where you want to go. But if you don't know where the end journey is going, then how do you have a hope of getting there?
That's right. If you don't have a dream, how's your dream going to come true?
Oh, I've heard that somewhere.
So what does net zero mean to your school? Well, there's a whole raft of things that we need to take into consideration. The emissions that we've got, the water, the electricity that we're using, transportation, as Rich mentioned earlier. What are we doing with our waste? How much are we recycling? We're going to need to get gas out of the whole entire system. It's a big task.
So I like to think of it as everything going into the school. So that's people, stuff, fuel. That all takes energy, yeah? That all takes energy that has carbon involved around it. So what are you going to do to minimize that carbon? Okay, think about it. And why not start by actually promising something? Draw a footprint, put down a pledge. What are you going to do? What are you going to do this week? What are you going to do next term or this year? What are you trying to achieve?
So let's get some of the stuff into the curriculum. Let's educate people about it. Eco team. Have you got one? If you haven't got one, create one. Start educating the people in your school. Start making the changes in your school that we need to make. There's help and support out there. We work with Ashton on the Less CO2 program, Low Energy Sustainable Schools. You can sign up to this stuff for free. Energy Sparks, this is about looking at your energy. Just seeing why the energy you're spending, you're using is being used. There's an incredible amount of waste across schools. We've been doing this stuff at the School Energy Efficiency for 8 years, and it's the same across the country. New schools, old schools, there are inefficiencies and there are improvements to be made across the board. And by using something like this, where you're looking at the data, you can see where it is that you're spending your money. And if we can reduce the amount of money you're spending, you can spend that money on other things important to our education rather than heating up the atmosphere.
So this is using smart meter data, but data is just numbers unless you turn what you see, like in this graph, into actions. So it's all about taking actions as a result of this information. And it's an impressively powerful tool to be able to use. So solar for schools. So this is all about what we can do now. We love the idea of renewable energy, but your school is perfect. You've probably got loads of roof space, and it's something that solar panels have been around for years, James. It's proven technology. It doesn't move. It just sits there. Low maintenance stuff. You can get it now. Now, when we used to have feed-in tariffs, you used to get paid by the government to actually generate. That doesn't happen anymore, unfortunately. But we don't have a lot of money in our schools. I know, I'm a chair of governors, I get this, but you can get lovely businesses like Solar for Schools, for instance, that can actually put solar panels on your roofs for free, and you can use that energy in your school and get a discounted rate. It's to me, it's a bit of a no-brainer, because if you think there's 20, 30,000 schools in this country, and if all of them had solar panels, how much energy that would be that we would generate for the use of not just the school, but your local community and the rest of the country.
So one of the things we'd really like you to do is to sign up for Let's Go Zero 2030. And this is just a campaign. We talked about lobbying the politicians, and this is an important campaign that we're hoping will add pressure to them and create some of that change. It's just making a simple pledge to move your school forward. So again, this is a great piece of
well, it's a campaign, isn't it? With the COP26 is coming to Glasgow. You may be looking at this after we've had it, and hopefully it's been a great success. But we are a few months away now from that big conference where all the big countries in the world and the little countries are coming together to actually say what they're going to do about the targets that were set back in Paris. So this campaign is to put pressure on, but using the school's voices, your voice, to actually let them hear that you want the change. It's your future. A lot of these guys won't be seeing this changed future. It's you. So it's your pressure to put onto them to say, go with the big change. Don't do the little changes, do the big ones. So add your voice to this campaign.
Again, it's free. So this is where we're at. We're at a tipping point now. Where are we going to go from a environmental point of view? Are we going to start making those changes, and are we going to stay on the good side, the green side, the less environmental impact as possible? Or are we just going to say, it's a bit too much like hard work, can't be bothered, you know? And also, at a political tipping point too, we need that help and support. We need to make sure that the government knows how serious you are about this and about asking them to make the right steps. That's what we need.
Right, we've reached the end. I think we've just come up to 30 minutes.
If you've survived all 30 minutes with us, thank you very much. You're incredible.
So that's it, in a very quick set of slides to explain a lot of where we've been, where we are, where we're going, and that you really can make a difference.
Thanks very much.
See you again.